So good morning to everybody. So this class we are going to handle electrostatic potential. So electric potential, the symbol is U. Electric potential, the symbol is U. For example, there is a positive charge plus Q here. So there is a field over it, electric field. Whenever there is a charge, the surrounding is in the electric field. Then from that electric field, at particular point, we take a point. This is a point B at a distance x. Point B at a distance x. So what is electric potential is, actually electric field we know. There is a force of, I keep a unit positive charge here, plus 1 unit positive charge plus 1 coulomb. Unit positive charge here, there is a force of attraction between these two, force of repulsion plus charge. Force of repulsion between these two charges, force of repulsion. So that force, if you divide the force divided by Q, that is F divided by Q is equal to E is equal to F divided by Q. So force per unit charge, suppose you take, that is electric field vector. So the electric field is all around the charge, we already know that. But what is electric potential? Now bring a unit positive charge, say a small distance from here, we take a unit positive charge. Here you remove this charge because I give for example for force. Okay. Now for electric potential, you take, actually what is the definition is, you take a unit positive charge from infinity, long distance, from infinity to that point. The work done needed to bring a unit positive charge from infinity to that point is called electric potential. So work done, electric potential is nothing but a work done to bring a unit positive charge from infinity to the point. So from the infinity we take for easy calculation, we take one point R. So we take that R. P is a point. For example, P is from the 1 meter from here. This is 1.5 meter from here. So our point. So this is a distance, small distance, dx. Small distance, dx. Actually, this definition, if your notation we make it correct, then teaching electrostatic potential is easy. If you are not making that, this notations x dx is incorrect, then teaching a potential is very difficult. So what a plus there is a field is there. So we try to bring a positive charge. Positive charge, if you try to bring positive charge, for example 1 coulomb of charge, positive charge, then automatically a force of repulsion is there. It's not allowed. But to be force, we give external work. That is F external. We do some work and bring the charge against the field. Against the field. Bring the charge against the repulsion. Against the force of the repulsion. So this is nothing but dx, and I try to push, I do some external work. That is, I do some external work. That is small work, for example dw, for small distance, tw. To move a distance dx, I do a small work, dw, right? To move a plus 1 charge, plus 1 coulomb charge from this point to this point, that is small distance dx, I do some work. That work is denoted by dw. Actually from mechanics we know what is dw. dw is equal to dw, from mechanics point of view, dw is equal to F external into dx, force into distance. Dot product I make it, so both are vectors. X also vector, dx also vector, dw is also vector. So if I want to, but I don't know how much really work I do for this external to bring this charge from R to P, to bring from R to P, to bring from R to P. I don't know how much external work I done, but I done some work. But here a real understanding is I done some work, external work, but we know internally there is a force of repulsion between this unit positive charge for a small distance dx and plus q. There is a force of repulsion between plus 1 and plus q. So that is Coulomb law of electrical repulsion. Yes. So that F external I don't know, but equal and opposite force one is there, against only I am moving. So F external I can replace by F Coulomb. So Coulomb law of repulsion. Coulomb law of repulsion. So this is one of the very, very important understanding as far as this derivation is concerned. So F external I don't know how much I worked, but I know the F Coulomb, that the force opposing that. So I replace this F external into F Coulomb. That from the, we know some equations for F Coulomb. So F Coulomb dot dx, this can be written as F Coulomb dot product, we can write F dx cos theta, F dx cos theta. If you understand these points very correctly, then only we can understand F dx cos theta. What is theta? Angle between dx and F Coulomb. Angle between dx and F Coulomb. For example, here F Coulomb is moving in this direction, is force of repulsion. Q is repelling plus 1. So for distance dx you take F Coulomb acting this direction, but dx we are bringing this direction. For example, this is dx vector acting in this direction. So this is ds vector acting direction. This is F Coulomb acting direction. But the angle if you take this for small distance, the angle you take, that is 180. This is 180. Total angle is 360. So half of the angle is 180. Cos 180 is minus 1. So you substitute theta is 180 to here. Angle between F Coulomb and dx. This is F Coulomb this direction. This is opposite direction. So 180 is the angle. So I can write as F Coulomb into dx into cos 180. So the cos 180 is minus 1. So F Coulomb into dx into minus 1, that is equal to minus F Coulomb into dx. A lot of persons will confuse without explaining this. Simply they are telling that F Coulomb is opposite to F external, say we put minus F Coulomb. That is not. Mathematically and vectorially we have to represent, then we develop, then only correct. Most of the others or most of the YouTubers, they simply explain F external equal and opposite. That is, so F Coulomb is equal and opposite. They said like that. But mathematically we have to prove everything. F Coulomb is equal and opposite, that is right, but minus sign also, but don't put like that. Tell the relation between F Coulomb and F dx through the direction, the angle is 180. Then F Coulomb dot dx, F Coulomb dot dx equal to F Coulomb dx cos theta. F Coulomb dx cos theta. Theta is 180 between dx and F Coulomb. So F Coulomb into dx is equal to cos theta. That F Coulomb into dx into minus 1. That is minus F Coulomb into dx. Okay. So we run this and we'll develop the further action. Actually, we have to make dot dot dot. We have to bring from infinity to that point. We have to do from infinity to that point. Okay. What is F Coulomb? So this side dw is coming. dw. What is F Coulomb? F Coulomb minus 1 by 4 pi epsilon naught q into 1. This is 1. Okay. This is q plus q. So plus q. You put plus q into 1 divided by r squared. What is distance between this variable distance? The x is p is here, x, oh, okay, x squared. X squared, now dx is there, dx. So if you write here, dw is equal to minus 1 by 4 pi epsilon naught, 4 pi epsilon naught q divided by x squared into dx. So this is small work to bring r to p. R to p. Now we go over total work, that is from infinity to from infinity to p. You have to take up to the here, infinity to p. So lower limit is infinity, upper limit is x. Upper limit is x. So we have to integrate both sides for total work. So integration of dw at w. I write integration of dw is equal to w is equal to minus q and 1 by 4 pi epsilon naught is constant. We take outside. Q divided by 4 pi epsilon naught. These all things are there. So integration, lower limit is, you integrate simply like this. Lower limit is infinity, upper limit is x. Infinity to x. Infinity to x. So that is nothing but 1 by x squared. I write 1 by, now I write 1 by x squared, but 1 by x squared is x to the power minus 2. So into dx. So the minus sign is there. Q I take outside because it's a constant. 4 by epsilon 0 is also a constant. So 1 by x squared. So here I put an integration for this. So that is equal to minus q divided by, that is w, is nothing but w, that is minus q divided by 4 pi epsilon, 4 pi epsilon integration of x to the power minus 2, x to the power minus 2 dx. So x to the power n plus 1, x to the power n formula, integration of x to the power n. So please apply limit also, infinity to x. So integration of x to the power n dx. What is the general formula? X to the power n into dx is equal to x to the power n plus 1 divided by n plus 1 plus c. C we are not forget, n plus 1 divided by n plus 1. So that is equal to minus 2 plus 1 divided by minus 2. So n we have to substitute minus 2. So n is, x to the power n is minus 2. So x to the power n, that is x to the power minus 2 plus 1 divided by minus 2 plus 1. So we have to write like that. That is minus q divided by 4 pi epsilon naught, lower limit. Now we integrated, we apply integration. So x to the power minus 2 plus 1 divided by minus 2 plus 1. Lower limit is infinity, upper limit is r. So that is minus 2 plus 1, how much? So nothing but minus 1, here also minus 1. So x to the power minus 1 divided by minus 1. So we rub it. Rub it. So that is equal to minus q divided by 4 pi epsilon naught x to the power minus 1 divided by minus 1 infinity to x. I put r, no, symbol you have to put correctly, then only everything correct. That is equal to this minus and this minus is plus q divided by 4 pi epsilon naught x to the power minus 1 is nothing but 1 by x. So we put 1 by x and lower limit is infinity, upper limit is x. So now we apply the limit. So it's nothing but w. So w is equal to plus q divided by 4 pi epsilon naught 1 by x. First you apply x, so this is 1 by x minus 1 by infinity. 1 by infinity is 0. So this becomes 0. So we are having only 1 by x. So total w work done. This work done is we called potential. That is w is equal to q divided by plus, just remove the plus, no problem, 4 pi epsilon naught into 1 by x. So this work done is stored as a potential. Work done is stored as a potential at the unit positive charge. So that we use potential, we use the symbol u. That is equal to q divided by 4 pi epsilon naught 1 by x. So 1 by 4 pi epsilon naught q divided by x. So this is the final conclusion. So why you bring from infinity, that question already always in my mind. Why you bring a unit positive charge from infinity? Actually, what is potential? In a natural we never say potential, potential difference. Voltage is potential difference. Like that, potential difference we will find. But with reference to one reference that we called potential. One reference is from infinity, means infinity potential is 0. If you take this field, the field is around some distance only. From infinity, field is 0. So reference potential is 0. So that's why we take this infinity. Please understand, this is one of the main things students actually, this is, for example, this is earth ground. From the ground I raise one stone to a height h. So my potential energy is, by this ground potential is 0. So this is, for example, mass is m, then mgh is the potential of the stone. Suppose I bring this height, a stone, mgh minus 0. Actually we are not minus 0. So minus 0 is the potential ground reference. So we are not taking minus 0. But minus 0 is there. Suppose you take potential difference between those 2 points. Here potential difference is different. This height only, this, for example, this is h1. Here potential difference is mgh1, not mgh. So every point potential is different, but we always say potential with respect to ground, that is potential difference with respect to ground, mgh minus 0. Like that in electrical also, potential difference only we are calculating, but here potential difference with respect to infinity. So infinity potential is 0. Potential is 0. That's why potential at a point P with respect to 0 potential. So this 1 by 4 pi epsilon naught q divided by x minus 0 with respect to infinity, that is why minus 0. But if you substitute infinity, that is 0 only. So minus 0, that 1 by 4 pi epsilon naught q by x minus 0. So 0 we are not referring, minus 0 no problem, that's why we put that is why they are telling in the definition to take a unit positive charge from infinity to that point means from 0 potential to that point. So that gives the potential difference, and we in usual manner we are not say each time potential difference with respect to this point, that point, we are not telling like that. We say potential means potential at a point with respect to infinity, that is with respect to 0 potential. Okay, thank you so much. This is understanding you must be having in mind. Thank you.